factors affecting diffusion rate. Now, the rate at which substances move into and out of the cell is greatly influenced by a number of factors, which include: the first one is the diffusion gradient. Now, as you saw earlier, diffusion gradient is the difference in concentration between two different regions. So for instance, you can have two different diffusion gradients. Here there is this gradient, so let's call it this gradient A, and another one that is gradient B. Now, the greater the gradient, the higher the rate of diffusion. Gradient A is steeper and greater than gradient B. Hence, particles will diffuse at a faster rate from, say, region A to B than from region C to D, because of the difference in the gradient. So the higher the gradient, that is the difference between the concentration at A and B and C and D, the faster the rate of diffusion. So in this particular case, particles will be moving at a faster rate from region A to B than from region C to D. The second factor that affects the rate of diffusion is temperature. The higher the temperature, the higher the rate of diffusion, because an increase in temperature increases the kinetic energy of particles, thus making the particles to move faster from a region of high concentration to region of low concentration. 3. Size of the particles. The smaller the particles or molecules, the higher or faster the rate of diffusion. Reason: small particles have lower weights, thus move at a faster speed. Just like by comparison, in motor vehicles, a small car moves at a higher speed than a truck because of its lower weight. Then number 4 is the surface area to volume ratio. Surface area to volume ratio, whereby the higher the surface area to volume ratio, the greater the rate of diffusion. Now we can illustrate this relationship using two cubes of different volumes. We have cube A, let's call this is A, of 1 by 1 by 1 centimeter dimension. So the surface area here is equal to 1 times 1 times 6, that gives you 6, and then the volume is 1 times 1 times 1, so this is 6, gives you 1. Hence, surface area to volume ratio is 6 to 1. Then compare this to a second cube, a larger cube of, say, dimensions 6 centimeters to 6 to 6. This gives us a surface area of 6 times 6 times 6, that gives you 216, and volume of 6 times 6 times 6 giving you 216. Hence, the surface area to volume ratio is 216 to 216, which is equivalent to 1:1. So you see that the surface area to volume ratio of cube A is larger than that of cube B. Particles would diffuse into and out of this cube at a faster rate than in the case of B, because there's greater volume, greater distance to be covered by the diffusing particle where the volume is large. So relative to the surface area, here the volume is very big, and hence the rate of diffusion of particles into and out of a large body is going to be slower compared to that of a smaller body. Now, the fifth factor that affects the rate of diffusion is thickness of the membrane, or even thickness of the tissue. The thicker the membrane, the lower the rate of diffusion. Reason: when the membrane is thick, then the distance to be covered is greater, so the diffusing particles take a longer time to move across. Compare this to these two membranes, or a tissue like epidermis, where we have, let's say, the membrane X and membrane Y. A particle from this point diffusing across to the other point will take a longer time than the particle, another particle from this point in membrane Y diffusing across to the other side. All factors like temperature being constant, then the movement across Y is going to take a shorter time compared to the movement across X.